Spain adds Digestate pasteurization to new biogas plant site. A newly operational anaerobic digestion plant in southern Spain has installed the country's first digestate pasteurization system supplied by HRS heat exchangers. The installation adds a dedicated treatment stage for the plant's digestate, helping the operator meet European animal byproduct rules while preparing the material for potential use as an agricultural fertilizer. Construction of the facility began in 2025. At full output, it is expected to produce 58 gigawatt-hours of biomethane each year. The gas will be injected into Spain's national grid, with annual production estimated to match the energy needs of about 11,000 homes. Pasteurization prepares digestate for agricultural reuse. The plant processes agricultural and livestock residues, including olive pomace, whey, pig slurry, and chicken manure. Anaerobic digestion converts those feedstocks into renewable gas, but it also leaves behind digestate containing nutrients that may be returned to farmland. Because the input materials include animal byproducts, the digestate must be pasteurized before it can be used in agriculture. The treatment is required under European regulation EC Num. 1069/2009 and is intended to reduce the risk of pathogens being transferred to soils, crops, or livestock. The HRS system can process up to 220 metric tons of digestate per day. 3 holding tanks support continuous operation, with filling, pasteurization, and emptying taking place in separate vessels. A corrugated double-tube heat exchanger raises the digestate temperature to 167 degrees Fahrenheit. The system is all designed to manage changes in feedstock temperature and consistency, an important consideration for facilities handling several types of organic waste. For farmers, the project may provide another route for managing livestock and food processing residues. The resulting digestate could also offset some use of synthetic fertilizer, although the overall environmental benefit will depend on transport distances, nutrient application practices, and the amount of conventional fertilizer it replaces. Heat recovery could reduce the plant's thermal load. To lower the energy required for pasteurization, the system transfers heat from treated digestate to colder material entering the process. HRS estimates that the heat recovery arrangement can reuse up to half of the process's thermal energy. The supplier projects annual savings of approximately 1.75 million kilowatt-hours of heat and avoided emissions of about 375 metric tons of carbon dioxide. These figures are supplier estimates rather than independently verified operating results. Actual performance will depend on factors including plant utilization, incoming digestate temperature, feedstock composition, and day-to-day operating conditions. HRS delivered the equipment as a turnkey package covering pumps, tanks, controls, instrumentation, valves, pipework, and heat exchangers. According to the company, the client selected the system after reviewing comparable installations at anaerobic digestion plants in other countries. The project also reflects the wider expansion of Spain's biomethane sector. HRS reported that the country had 12 operating biomethane plants in 2024 and 25 in 2025. It expects that figure to reach 46 by the end of 2026, with up to 90 further projects potentially entering operation during 2027. Those projections remain subject to permitting, financing, feedstock supply, and access to the gas grid. As more projects move forward, digestate management is likely to become a bigger part of commercial and regulatory planning rather than an afterthought to gas production. For developers, effective treatment of digestate can influence operating costs, agricultural partnerships, environmental compliance, and local support. The Spanish installation provides an early case study of how pasteurization and heat recovery can be built into a larger biomethane facility.